DBSCAN is a clustering algorithm that finds groups by looking at density. The main idea is simple. If many data points are close together, DBSCAN sees that area as a cluster. Think about people at a festival. If many people are standing close together, we naturally see them as a crowd. But if one person is standing far away alone, we probably would not call that person part of the crowd. DBSCAN works in a similar way. It looks for crowded areas in the data and turns those crowded areas into clusters. A very useful part of DBSCAN is that it does not force every point into a cluster. If a point is too far from the crowded areas, DBSCAN can mark it as noise or an outlier. To decide what counts as close, DBSCAN uses a setting called epsilon. You can think of epsilon as a small circle around a point. If another point is inside that circle, it counts as a nearby neighbor. But being close to just one point is not enough to form a cluster. DBSCAN also needs a minimum number of neighbors. This is called MinPts. In simple terms, epsilon asks, how close is close enough? MinPts asks, how many nearby points do we need before we call this area dense? If a point has enough neighbors inside its epsilon circle, it becomes a core point. Core points are the strong center of a cluster. If a point is close to a dense area but does not have enough neighbors on its own, it is called a border point. It still belongs to the cluster, but it is not the center of it. If a point is far away and does not belong to any dense area, DBSCAN marks it as noise. This is what makes DBSCAN different from k-means. K-means forces every point into a cluster and usually works best with round groups. DBSCAN can find irregular-shaped clusters and can leave out unusual points as noise. So the key idea is DBSCAN finds dense regions, connects nearby dense points, and separates isolated points as noise. DBSCAN is useful when clusters are not perfectly round or when your data contains outliers, but it depends heavily on choosing good epsilon and MinPts values. In the next video, we'll look at HDBSCAN, which is a more flexible version of density-based clustering. Like this video, follow for more, and subscribe so you don't miss the rest of the series.